Hi, I'm Patrick Reagan. Welcome to TCP/IP, Part 7, IPv4 Simple Subnetting. During our last video, we went deeper into IPv4 addresses and subnet masks. During this video, we will take a network and break the network into smaller subnets. This is also a great video to pause the video when needed to look at the addresses, subnet mask, and their binary equivalents, and to perform your own binary to decimal conversions. If you remember from our last video, the primary classes are A, B, and C. If the IPv4 address starts between 1 and 126, it is a class A with the default subnet mask of 255.0.0.0. A class B starts with 128 to 191, which has the default subnet mask of 255.255.0.0. And a class C starts between 192 and 223 with the default subnet mask of 255.255.255.0. Remember, the subnet mask tells you which bits are the network bits and which bits are the host bits. For example, the 15.54.233.5 address, the network part of the address is 15, and the host part of the address within the network is 54.233.5. For all hosts with this network, has to begin with 15. As you can see with the 143.56.187.54 address, the network part of the address is 143.56, while the host part of the address is 187.54. For all hosts within this network, must begin with 143.56. Of course, Class C has the first 3 octets locked in for the network portion. Therefore, in the Class C example, with the subnet mask of 255.255.255.0, the network part is 192.168.43. With the classes, many addresses are wasted. For example, how many single networks do you know have more than 16 million addresses as assigned to a Class A network, or even 64,000 for a Class B? The subnet mask can be changed to take a large network and break it into several smaller networks called subnets. This allows a corporation or organization to be free to assign a distinct subnet number for each of its internal networks. This allows the organization to deploy additional subnets without needing to obtain a new network number from the internet. Remember, the subnet mask is used to define which bits represent the network prefix, including the subnet number, and which bits represent the host number. The network prefix and the subnet number are sometimes referred to as the extended network prefix. For a subnet, the network prefix, subnet number, and the subnet mask must be the same for all computers. You should also recall from the last video that the RFC 1918 has reserved addresses for private use as indicated by the table shown on the screen. These addresses are not available on the internet. Most enterprise networks use addresses from these blocks for their internal hosted network. RFC 1918 private addresses are often used with a network address translation, or NAT, that allows internal network devices to communicate with external devices on the internet by translating private IP addresses to a public IP address assigned to the router or firewall. So let's take a look at our first example. Let's say you have a bank with multiple bank locations or branches, and your corporation is assigned the following network address: 172.16.0.0. This is a Class B address because 172 falls between 128 and 191. Therefore, by default, it is assigned a subnet mask of 255.255.0.0 or CIDR notation /16. So you can see the address and subnet mask in their binary equivalent. Remember, the subnet mask specifies which bits are the network bits and which bits are the host bits. As you can see, by default, the first 2 octets, 172.16, define the network portion of the address. For every host that you assign to your corporate network, this begins with the binary address of 1010.1100.0001.0000 or 172.16 since it follows the octet boundary. The last 16 bits are for me to divide and assign as I see fit. The network address of the entire bank is where all host bits are set to 0 as shown on the screen, which is equivalent to 172.16.0.0. The broadcast address to all hosts at the bank is where all host bits are set to 1 as shown on the screen, and the broadcast address is 172.16.255.255. I'm going to use the third octet to specify the branch or subnet, and the last octet to define the host within the specified branch. Since I'm going to use the third octet as the network address, the subnet mask has to be modified to specify that those bits are now network bits. Since the third octet is being used for the network addresses, now for my subnets, I will have to set the binary equivalent to all ones as indicated in the red. So the subnet mask changes from 255.255.0.0 to 255.255.255.0. Now, let's look at the branch offices and the associated bits. Let's say that I have 6 branches. The first branch is the main office, which is numbered as 0. Remember, binary starts counting at 0. The next bank is Market Street, which is assigned number 1. Fair Oaks is assigned number 2, and so on. As you can see, the binary equivalent, which will be used for the third octet since that represents the subnet number. So every host at the main branch will begin with 10.1.0.0000.0000.0000, because the first 16 bits are dictated by the corporation, as shown in the green, and the next 8 bits are dictated by the site or subnet, as shown in the red. We've already said the subnet mask will be 255.255.255.0, which tells you which bits are network bits. So the first few hosts at the main branch will be numbered in binary as shown in the purple, which will be used in the fourth octet. The first host will be 0000000001, and the second host will be 00000010, and so on. So the full address of the first host is shown in binary on the screen, which is equivalent to 172.16.0.1, with the subnet mask at 255.255.255.0. Remember, you cannot have all zeros for the host bit because that represents the network address for the subnet. Therefore, you have to start with the next address, which is all zeros except for the last digit is a 1. The full address of the second host is shown in binary on the screen, which is equivalent to 172.16.0.2, with the subnet mask at 255.255.255.0. The full address of the third host in binary is shown on the screen, which is equivalent to 172.16.0.3, with the subnet mask at 255.255.255.0. So the full address of the last host would be what's shown on the screen, or 172.16.0.254, with the subnet mask at 255.255.255.0. Remember, you cannot have all ones for the host bits because that is the broadcast address for the subnet. Therefore, you have to take the address before the broadcast address, or all ones except the last digit is a 0. The network address represents the network as a whole, which will need to be defined in your routes and firewalls. To calculate the network address for the main office subnet, you would lock in the extended network address bits and set the host bits, purple, to all zeros as shown on the screen. Therefore, the network address for the main site is 172.16.0.0. A broadcast address is a multi-point connection to IP networks that automatically reach all nodes in the network without knowing the recipient addresses. To calculate the broadcast address for the main office subnet, you would lock in the extended network address bits and set the host bits purple to all ones. Therefore, the broadcast address for the main site is 172.16.0.255. If I go to the Market Street branch where the subnet is 1, every host at that site will begin with what is shown on the screen with red indicating the subnet number. The first few hosts at Market Street are also shown on the screen. All of these would have the subnet mask of 255.255.255.0. To calculate the highest address in the Market Street subnet, you would lock in the network address bits and set the host bits as shown in purple to all ones except for the last 0. Therefore, the highest usable address for the Market Street subnet is 172.16.1.254. Remember, you cannot have all ones for the host bit because that is the broadcast address for the subnet. Therefore, you have to take the address before the broadcast address, which is all ones except for the last digit is a 0. To calculate the network address of the Market Street subnet, you would lock in the extended network address bit and set the host bits to all zeros as shown on the screen. Therefore, the network address for Market Street is 172.16.1.0. To calculate the broadcast address for the Market Street network, you would lock in the extended network address bits and set the host bits to all ones as shown on the screen. Therefore, the broadcast address for the Market Street site is 172.16.1.255. To calculate the number of subnets, we would use the following formula. Number of subnets equals 2 to the subnet bits power. To calculate the number of hosts per subnet, you would use the following formula. Number of hosts per subnets, 2 to the host bits minus 2. The minus 2 is because all zeros represent the network address for the subnet, and all ones represent the broadcast address for the subnet. In our example, the third octet, 8 bits was used for the subnet, and the fourth octet, 8 bits were used for our host. Therefore, we can have up to number of subnets or sites is 2 to the subnet bits, which is equal to 2 to the 8th, which is equal to 256. In each subnet and site, we can have up to number of hosts per subnet is 2 to the host bits minus 2, which is 2 to the 8th minus 2, which is 254 hosts. Let's look at another example. Let's say you have a school with multiple campuses throughout the United States. The entire school is assigned 10.0.0.0. This is a Class A address because 1 falls between 1 and 126. Therefore, by default, it is assigned a subnet mask of 255.0.0.0 or CIDR notation /8. The binary equivalents are shown on the screen. Again, the subnet mask specifies which bits are the network bits and which bits are the host bits. Every host that you assign to your school network must begin with the binary address of 00001010 or 10 since it follows the octet boundary. The last 24 bits are for me to divide and assign as I see fit. The network address of the entire school is where all host bits are set to 0, as shown in the purple, which is equivalent to 10.0.0.0. The broadcast address to all hosts at the school is where all host bits are set to 1, also shown in the purple, which is equal to 10.255.255.255. I'm going to use the second octet to specify the campus or subnet, and the last 2 octets to define the hosts within the campus. Since I'm going to use the second octet as the network address or subnet, the the subnet mask has to be modified to specify that those bits are network bits. I will be changing the subnet mask from 255.0.0.0 to 255.255.0.0. Now let's look at the campuses and the associated bits. Let's say I have 5 campuses: Los Angeles, New York, San Francisco, Miami, and Dallas. Again, binary counting starts counting at 0. So let's look at the second campus, New York. Every host at the New York campus will begin with the binary shown on the screen, which is equivalent to 10.1. Because the first 8 bits are dictated by the school, and the next 8 bits are dictated by the site or subnet or campus, the subnet mask will be 255.255.0.0. The first few hosts at the New York campus will be numbered in binary as shown on the screen. So the full address of the first host is also shown on the screen, which is 10.1.0.1. Remember, you cannot have all zeros for the host bits because that represents the network address for the subnet. Therefore, you have to start with the next address, which is all zeros except for the last digit is a 1. To calculate the highest address in the New York subnet, you would lock in the network address bits and set the host bits to all 1s except the last 0 as shown on the screen in purple. Therefore, the highest usable address for the New York site or subnet is 10.1.255.254. Remember, you cannot have all host bits set to 1 because that is the broadcast address. Therefore, you have to take the address before that, which is all 1s except for the last digit is a 0. To calculate the network address of the New York subnet, you would lock in the extended network address bits and set the host bits to all 0s as shown in the screen in purple. Therefore, the network address for the New York subnet is 10.1.0.0. To calculate the broadcast address for New York subnet, you lock in the extended network address bit and set the host bits to all 1s as shown in the screen in purple. Therefore, the broadcast address for the New York subnet is 10.1.255.255. To calculate the number of subnets, you use the following formulas. Number of subnets equals 2 to the subnet bits. And to calculate the number of hosts per subnet, you would use the following formula. Number of hosts per subnet, 2 to the host bits minus 2. Of course, the minus 2 is because all 0s represent the network address for the subnet, and all 1s represent the broadcast address for the subnet. For our subnet number, we use the second octet, which is 8 subnet bits, and for the host, we use the last 2 octets, which is 16 host bits. So in our example, number of subnets or sites is 2 to the subnet bits, which is equal to 2 to the 8th, which is equal to 256 sites. And each subnet or site can have up to number of hosts per subnets or sites is equal to 2 to the host bits minus 2, which is equal to 2 to the 16th minus 2, which is equal to 65,534 hosts. When planning your TCP/IP network, make sure that you plan for growth where you might add subnets or sites and additional hosts in the future. Question: if you have a Class B network with a subnet mask of 255.255.255.0, how many subnets can you have? Answer: 256. The third octet is used for the subnet, which gives me 8 bits. Therefore, 2 to the 8th power gives me 256. Question: you have a Class B network with a subnet mask of 255.255.255.0. How many hosts can you have? Answer, 254. Here we have 8 bits for hosts. We normally have 2 to the 8th power or 256 combinations, but for hosts, we cannot have all zeros or all ones, which means we have to subtract the 2, giving us 254 hosts. Question: what is the broadcast address for a network that has the network address of 192.168.1.0? Answer, 192.168.1.255. Question: what is the default subnet mask in CIDR notation for a Class B network? Answer, 255.255.0.0 or CIDR notation /16. For more information, refer to these sites. In summary, the subnet mask can be changed to take a large network and break it into several smaller networks called subnets. The network address represents the network as a whole, which will need to be defined in your routes and firewalls, and where all host bits are set to 0. A broadcast address is a multi-point connection in IP networks that automatically reaches all nodes in the network without knowing the recipient's addresses, and where all host bits are set to 1. To calculate the number of subnets, you use the following formula: number of subnets equals 2 to the subnet bits. To calculate the number of hosts per subnet, you use the following formula: number of hosts per subnets equals 2 to the host bits minus 2. Thank you for watching this video. The next video will be TCP/IP Part 8 IPv4 Complex Subnetting. If you have not already, subscribe to the Pat Has Your Back channel. Thank you.